Welcome, geometry students, to a Regents review video. These are the solutions for the June 2016 Regents exam, Part 1, questions 13 through 24 of the June 2016 Geometry Common Core Regents exam. Before we begin, if you are here to copy my answers, please refrain from doing so. The Geometry Regents is very difficult, and please visit my website at www.nysmathregentsprep.com. And without further ado, let's get started. So we're jumping right to question 13 of this exam. Now I will tell you that these particular questions, once it hit 13 on this exam, it got a little challenging, but we'll get through it. And let's begin. So it says here, in triangle RST shown below, altitude SU is drawn to RT at U. If SU is H, UT is 12. So I'm going to put UT as 12 right there. And the length of RT is 42. Which value of H will make triangle RST a right triangle with angle RST as a right angle? So this is testing your knowledge on whether or not you understand triangle proportions, because there's an altitude involved. So if you know how to use your triangle proportions, then you are okay with this question. So I teach it, or I call it, the heartbeat method. Okay? When you're given the altitude of a right triangle, you could solve for the altitude or the corresponding legs by using the heartbeat method. Or you might have learned this, or your teacher might have taught it to you as the SAS method. Segment over altitude equals altitude over segment. I just call it the heartbeat method because it does look like a heartbeat when we figure it out. So before we begin, we need to understand that 42 is the length of the whole thing. We need RU, which is 42 minus 12, which is 30. And that was really important to getting this question right. So in order to solve for the value of H, we need to use the heartbeat method, which I call it the flat line over the pulse equals the pulse over the flat line. You go up and you come back down again, and that will be your triangle proportion. For those of you using SAS, that's your segment over your altitude equals the altitude over the segment. So set up your triangle proportion. 30 over H equals H over 12, and we are going to cross multiply. 30 times 12 is going to be 360 is equal to H squared. And now we're going to take the square root of both sides. And the square root of 360, we have to think of the highest perfect square that goes into 360. The highest perfect square that goes into 360 is 36, and then the other number that multiplies to 36 yields 360 is 10. So when we simplify radicals, this radical 36 will simplify to 6, radical 10 carries along for the ride, and that would be your value of H. And that's how you simplify radicals and triangle proportions, and that is choice 2. All right, moving on. 14, the diagram below shows triangle ABC that has the vertices A 4, 5, B 2, 1, and C 7, 3. What is the slope of the altitude drawn from A to BC? So you need to know this very, very important fact. Altitudes are perpendicular to its base. That's a very important fact that you need to know. Altitudes are perpendicular to its base. So if it says draw the altitude from A to BC, well, we have to calculate the slope of BC. Well, to get from B to C, we go up 2 and to the right by 5 units. So the slope of BC is going to be 2/5. Okay? So if the slope of BC is 2/5, then the slope, I'm going to call this AD. I'm going to make that D down here. The slope of AD has to be the negative reciprocal of 2/5 because, again, altitudes are perpendicular to its base. So the negative reciprocal of 2/5 is going to be negative 5/2, which is the answer. So your answer for number 14 is going to be choice 4, negative 5/2. All right, moving on to question 15. This question, I have to tell you, it is quite challenging because you really have to know what they're talking about here. Let me read it to you and I'll explain what's going on. So it says here, in the diagram below, triangle ERM is similar to triangle JTM. Which statement is always true? And in this particular question, if if you went through the answer choices, you understand that the angles are not in the same triangle as the side measurements that they give you as the answer choices. So you might have been confused when doing this question. Well, this is what you have to know. Similar triangles are in proportion. Okay? And also, the corresponding angles are congruent. Because it's a a series of similarity transformations was performed, and they tell you that the triangles are similar, so the corresponding angles are congruent. So what that means to us is that angle J is congruent to angle E because these two angles are corresponding to each other. Angle JTM is congruent to angle ERT. So that is up here and up here. And angle TMJ is congruent to angle RME. Okay? So those are these right angles down here. Okay? So, well, what do we know? It says, which statement is always true? Okay. Let's take a look at choice 1. It says here that the cosine of J, so if we take the cosine of J, we are using SOHCAHTOA, by the way. Okay? The cosine of J should be the adjacent, which is JM, over the hypotenuse, which is JT. But if you look at the answer choices, all of a sudden they're talking about RM and RE. That's not even in the same triangle, so what are they talking about? Well, you need to know that the cosine of J is also the same as the cosine of angle E. Because, again, the triangles are similar, so the corresponding angles are congruent to each other. So, what is the cosine of E? Well, the cosine of E is equal to the adjacent, which is ME, over the hypotenuse, which is RE. That's not what it's showing. It's showing RM. That should be ME for that to be true. So choice 1 is wrong. All right, let me erase all this stuff now. Let's take a look at choice 2. The cosine of R. Now, wait a minute. Since this pattern is occurring, we know that they really are testing us well. The cosine of R is also equal to the cosine of T. So the cosine of T is equal to the adjacent, which is TM, over the hypotenuse, which is JM. That's not shown here, so that is false. Let's take a look at choice 3. The tangent of T, okay? The tangent of T is the same thing as the tangent of R, because again, angle T is congruent to angle R. So what is the tangent of R? Well, the tangent of R is equal to the the opposite, which is ME, over the adjacent, which is RM. That is not being shown here, so choice 3 is wrong again. So now let's take a look at choice 4. The tangent of E, which is the same thing as the tangent of J. The tangent of J is equal to the opposite, which is TM, over the adjacent, which is JM. And what do you know? Choice 4 is correct because these two ratios match. That was definitely a more tricky question. So that's why it is going to be choice 4 because of the similar triangle theorems that you need to apply to get this question right. All right, moving on. Number 16. On the set of axes below, rectangle ABCD can be proven congruent to rectangle KLMN using which transformation? So one of the most common mistakes with this question is people picked rotation. And it certainly does look like a rotation, but it is not a rotation. It is actually a reflection over the x-axis. And I'll be happy to show you why. Because if we analyze this graph here, you see these points? These points never change, meaning that they don't change location. These are called invariant points. The word invariant means points that do not change. So invariant points. If you have 2 points that do not change, and especially since they're on the x-axis, it is a reflection over the x-axis. Also, how you know that it's a reflection is that these points are equidistant from the x-axis. All of these points are equidistant from the x-axis. For example, the distance from the x-axis to point A is 1 unit. The distance from the x-axis to K is 1 unit. The distance from the x-axis to point N is 3 units, and so on and so forth. So this is 1, 2, 3. These are 5 units over here, and this is 1 unit again. So we know for sure, just based off this information, it is going to be a reflection over the x-axis. It is not a rotation. All right, moving on to question number 17. In the diagram below, DB and AF intersect at point C, and AD and FB are drawn. It says if AC is 6, DC is 4, FC is 15, and the measure of angle D is 65 degrees, and the measure of angle CBE is 115 degrees, what is the length of CB? Okay, so when you're looking at these triangles, what should be buzzing around in your head is, are these triangles similar? And yes, they are. Because this angle over here, this angle right there, this is a straight line. And a straight line forms 180 degrees. This is a linear pair. Well, what is 180 minus 115 to get the angle next to it? Well, that's just going to be 65 degrees. So this angle right here is 65 degrees. Also, angle C in the middle, well, angle DCA is congruent to angle FCB because those are vertical angles. So therefore, we can conclude, based off this information, that triangle DCA is similar to triangle BCF by angle-angle similarity, okay? So what does that tell us? Well, similar triangles are in proportion to each other. So if we're trying to find the length of CB, which I'm going to call X, we could set these two triangles in proportion. You have to be so incredibly careful when doing this because triangle DCA was dilated and it was rotated, ladies and gentlemen. So the 6 is corresponding to the 15. The 4 is corresponding to the X. I can't tell you how many times people set up the proportion of 4 over 15 equals 6 over X. Do not be that person. The correct proportion to set up is 4 over X is equal to 6 over 15, or some other sort of variation with that. Now we're going to cross multiply. 15 times 4 is 60, is equal to 6x. Divide by 6 on both sides. You get x is equal to 10, which is the length of CB. So that is going to be choice 1. All right. That's how you do question number 17. All right. Number 18. Seawater contains approximately 1.2 ounces of salt per liter on average. How many gallons of seawater to the nearest tenth of a gallon would contain 1 pound of salt? Man, this was some interesting question. So, what you had to do is you had to first convert the 1 liter. You had to convert because it's saying per liter on average. You wanted to convert 1 liter into pounds, okay? Because we want it in pounds. So, let's do this. It says there's 1.2 ounces per liter. So in 1 liter of the seawater, or one bottled liter of seawater, there are 1.2 ounces of salt within that. Now, what we're going to do is we're going to multiply by 16 ounces over 1 pound. Why am I doing this? Well, what's nice about this is, first of all, these are called conversion factors. If you have ounces and ounces in the numerator and the denominator, they cancel to each other, and you're left with liters per pound. We're getting closer to what we need to find the pound of salt. Now, keep in mind that 16 ounces in 1 pound, that could be found on your reference sheet up here. It says that 1 pound is equal to 16 ounces, just in case you didn't know that information. Okay? Now, let's go back. So now we just multiply across. 1 times 16 is 16, and that's in liters, divided by 1.2 ounces. When you type that into your calculator, that is 16 divided by 1.2. That is equal to 13.3 liters per pound. So that is going to be 13.3 liters per pound. Okay? Now your goal is to then convert the liters into gallons because it's asking you to the nearest tenth of a gallon. Okay? So, what I'm going to do is I'm going to take 13.3 repeating liters, and I'm going to put this over 1 pound because that's the number that we have right here. And I'm going to multiply. Now remember, I'm going to multiply by liters in the denominator to get rid of liters. Well, if I have, how many liters are in 1 gallon? Well, if we go back to our chart here, it says here that there are 3.785 liters in 1 gallon. That's important to help us. Well, we can multiply this by 1 gallon divided by 3.785 liters. Again, this will cancel out the liters. Now you just multiply across. 13.3 repeating times 1 is 13.3 repeating divided by 3.785, which is approximately equal to, let's type that into our calculator, 13.33 divided by 3.785, and that will give you 3.5 gallons. So that is approximately 3.5 gallons. And that 3.5 gallons will contain approximately 1 pound of salt. All right, so that is the answer to number 18. All right, number 19. Line segment EA is the perpendicular bisector of ZT, and ZE and TE are drawn. Okay, perpendicular bisector. Well, a perpendicular bisector forms right angles, and it bisects the line segment. So ZA is congruent to AT because the definition of a bisector, and it's perpendicular, so these are right angles. Now, EA is reflexive. Well, why am I telling you all this? Well, because we can conclude based off of this information that triangle EAZ is congruent to triangle EAT by side angle side. So, why am I telling you this? Well, we're trying to prove, which of the following cannot be proven. What we could then prove is everything else in this triangle is congruent by CPCTC. So, we can now prove the following. By CPCTC. We could conclude that angle Z is congruent to angle T. We could conclude that ZE is congruent to ET. And we could also conclude that angle ZEA is congruent to angle TEA. So I'm going to label all these things. Angle Z is congruent to angle T. This angle appears congruent to this angle. And ZE is congruent to ET. All proven by corresponding parts of congruent triangles are congruent. Great. Which statement cannot be proven? Well, let's take a look at choice 1. EA, line EA, bisects angle ZET. Is that true? Of course it is, because these two angles are congruent by CPCTC. So that is true. Choice 2 says triangle EZT, so the whole triangle is equilateral. That can't be proven, can it? That's an assumption. I will tell you what it is, though. Triangle ZET, this shouldn't say equilateral, it should say isosceles, because EZ is congruent to ET. So this should say isosceles, not equilateral. Okay? Choice 3 is saying that EA is the median of triangle EZT. Yes, because by definition, a median is drawn to its midpoint, and A is the midpoint of ZT, so that's true. And angle Z is congruent to angle T. That is true by CPCTC. So choice 2 is the correct answer. All right, number 20. And for question number 20, if you've noticed, if you've been doing old Regents exams, this is a repeat question from the August 2015 test. They made a little mistake, and I'm surprised that this got through. So it says a hemispherical water tank has an inside diameter of 10 feet. If water has a density of 62.4 pounds per cubic foot, what is the weight of the water in a full tank to the nearest pound? Remember what weight is. the formula weight is equal to density times the volume. Okay? Weight is equal to density times volume. So the weight is equal to the density, which is 62.4 times the volume. Well, what's the volume of a hemisphere? Well, the volume of a sphere is 4/3 pi r cubed. Therefore, the volume of the hemisphere is 1/2 of the volume of a sphere. Okay? So that's the volume is equal to 1/2 times 4/3 pi. Now the radius, well, it tells us that the diameter is 10 feet. So therefore your radius is 5, and then cube it. So I'm going to take this whole number, and I'm going to plug it into my formula. 1/2 of 4/3 pi times the radius of 5 cubed. I'm going to type this into my calculator. 62.4 times 1/2 times 4/3 times pi times the radius of 5 and cube it, and you get 16,336.28, which is approximately equal to 16,336. So that is going to be choice 1. All right. Number 21. In the diagram of triangle ABC, points D and E are on line AB and CB respectively, such that AC is parallel to DE. Remember what I've been saying for these questions. It says that AC is parallel to DE. Why are they telling you this? They're telling you this because they want you to conclude that triangle BDE is similar to triangle BAC by angle-angle similarity. Why? Well, because if you have parallel lines that are cut by a transversal, the corresponding angles are congruent, so angle BDE is congruent to angle A, and angle B is reflexive. So therefore, these two triangles are actually similar to each other, which means we could set them in proportion. So if AD is 24, DB is 12, DE is 4, what's the length of AC? Okay. Again, there is a common mistake that people make with this question, and they keep forgetting to do this. You have to add 24 and 12. Because if you're one of these people, please do not write this down. If you're one of these people that say, all right, 12 over 4 is equal to 24 over x, you are dead wrong. And I mean that so nicely. You are dead wrong because you are missing a whole piece of the triangle. The triangles are proportion. By you saying 24 over x, this is a trapezoid. Okay, so this is a trapezoid. You can't say 24. You have to state the full length, which is equal to 30. I'm sorry, did I say 12? Sorry, I meant 36. 36. You add 24 and 12, which is 36. So now, what I'm going to do is I'm going to set these in proportion. So I have 12 over 4 is equal to 36 over x. This, ladies and gentlemen, is your correct proportion. Okay? So, we now get, we're going to cross multiply these. So, I'm going to zoom out here. I'm going to bring it down here. So, we get 12x is equal to 36 times 4, which is equal to 144. Divide by 12 on both sides, and you get x is equal to the number 12, which is going to be choice 2. All right, moving on. 22. Triangle RST is graphed on the set of axes below. How many square units are in the area of triangle RST? So, listen. The way your teacher might have taught you this is this way. Most teachers teach to draw a box around your triangle, find the area of triangles 1, 2, and 3, then find the area of the whole rectangle or square, whatever it is, and then subtract the areas of 1, 2, and 3. You don't have to do that if triangle RST is a right triangle. So what we're going to do is I'm going to say, hey, wait a minute. Is triangle RST a right triangle? Well, let's verify this. The slope of RS is equal to positive 2. You go up 2 and to the right 1 every single interval. Then if you take a look at the slope of ST, that has a slope of negative 1/2. So therefore, this angle over here in the corner, angle S, is a right angle. So what that tells you is that area of a triangle, which is 1/2 base times height, can be used. You don't have to use what's called dissection. Dissection where if That method that I just showed you before, dissection, is you take the area of the whole rectangle and you subtract the area of those three triangles to get the area of this one. But we could use 1/2 base times height. So what I'm going to do right now is I'm going to read off the coordinates for you. Coordinate R is -2, 1, 2, 3, 4, 5, 6, 7. Coordinate S is -1, 2, 3, 4, 5, up 1. So -5, 1. Coordinate T is 1, 2, 3, 4, 5, 6, 7, down 1, 2, 3, 4, 5. So that's 7, -5. So what I'm going to do right now is I'm going to find the distance of RS, and I'm going to find the distance of ST, and I am then going to plug that into my area formula. So let's do that right now. So the distance of RS, so I'm going to do RS first. So the distance of RS is equal to the square root, let me zoom in here, is equal to the square root of -2 minus a -5 squared plus 7 minus 1 squared. So the distance is equal to the square root, -2 plus 5, that's positive 3. 3 squared is 9. 7 minus 1 is 6. 6 squared is 36. So the distance of RS is radical 45. We need to use that information later. Okay? Now, to find the distance of ST, again, we need to use the distance formula. So D is equal to the square root of -5 minus 7 quantity squared plus 1 minus -5 quantity squared. So D is equal to the square root, -5 minus 7 is equal to -12 squared plus, that's going to be 6 squared. That's D is equal to the square root of 144 plus 36. D is equal to the square root of 180. So now what I'm going to do is I'm going to take this information that we have, which is rad 45 and rad 180, and I'm going to plug it into my base and my height. So the area of the triangle is equal to 1/2. The base is rad 45 and rad 180 is the height. Or vice versa, it doesn't matter because multiplication is commutative. So now I'm going to go to my calculator. I'm going to go to control division. 1/2 times radical 45 times radical 180. And you get an answer of 45 square units. So that is going to be choice 3. That is the amount of area or square units that is in the area of triangle RST. All right, moving along, question 23. We're almost done. The graph below shows line segment AB, which is a chord of circle O. Now remember what a chord is. A chord is just a line segment that touches a circle at 2 points. The coordinates of the endpoints of AB are 3, 3, and 3, -7. Okay. The distance from the midpoint of line segment AB to the center of the circle is 2 units. What in the world does that mean? Well, if we go to our line segment here and we locate the midpoint, this right here, this blue dot, that is the midpoint of line segment AB. Now, it says here that the center of the circle is 2 units from its midpoint of line segment AB. So that means that this red dot could be the center. That means that this green dot could be the center because these are both 2 units away. Or this could be the center because, again, that's 2 units. Or this could be the center. So we got to determine, hey, is the red, purple, green, or orange dots, which of the following is the correct center to use? Okay, well, what they say here is that AB is a chord. AB is a chord. So let me just show you real quick. If you were to draw a circle on the purple dot, it has to touch points A and B. The purple dot fails to do that. So therefore, the purple dot is not the center of the circle. And that goes for the same for the orange dot. Because, again, B isn't touching the circle. So therefore, the purple dot and the orange dot are not centers of the circle. So now it's down to the red or the green. Well, the red dot is +1, -2. The center of the green, that's 1, 2, 3, 4, 5, down 1, 2. So that's 5, -2. So now if we go down to our answer choices and we remember that the center radius form of a circle is x minus h squared plus y minus k squared is equal to r squared. If we're using the red, your equation starts as x minus 1 squared plus y plus 2 squared. Well, the only ones that match that is choice 1. And choice 2 could be the green. Choice 3 doesn't work. And choice 4 could be the green as well. Now for the green one, again, that's x minus h squared plus y minus k squared is equal to r squared. The formula in center radius form for the green point is x minus 5 squared plus y plus 2 squared is equal to r squared. Let's match these answers. Okay, so choice 4 could work, so choice 2 is out. So it has to be either 1 or 4. It all comes down to the length of the radius, 29 or 25. Well, keep in mind that those are r squared values. So what I'm going to do is I'm going to draw myself a circle from the red point passing through A and B, and the same thing for the green. But keep in mind this theorem, that if you have a center of the circle drawn to the same external point, these two radii that you see here, these are congruent, so you could use a distance one time and just get it. So remember that A is a point 3, 3. We're trying to find the distance of A to the red point or A to the green point. They're both the same thing. So D is equal to the square root of 3 minus 1 squared plus 3 minus negative 2 squared. I'm using the red point for this. D is equal to the square root. 3 minus 1 is 2 squared, plus 5 squared. That's D is equal to the square root of 4 plus 25, which is the square root of 29. Wait a minute. That's the length of your radius. The center radius form of a circle, this is r squared. So if we take radical 29 and square it, that will give us 29. So the correct answer for this question is going to be choice 1. Choice 4 shows 25, which is not correct. That was a challenging question. All right, so that's going to be choice 1. And the last question of the multiple choice section. What is the area of the sector of a circle with a radius of 8 inches and formed by a central angle that measures 60 degrees? Well, the area of a sector formula, which I hope that you have memorized by now, is n over 360 pi r squared. Okay? So the area of a sector, of this sector, this 60 degrees, that's your n measure. Your radius is 8. Great. So we have 60 over 360 pi times the radius of 8. My apologies. That shouldn't be 6. That should be 8 and then square it. Now I'm going to type this into my calculator. But notice real quick before we begin that all of your answers are in terms of pi. That means when I go to my calculator, I'm not going to type in pi. So I'm going to type in 60 over 360 times times 8 squared. That is 32 over 3. So the area of the sector is 32 over 3, and then attach on the pi at the very end. Your answer is going to be choice 3 for that question. And that is the end of this video. Please hit that subscribe button, and please visit www.nysmathregionsprep.com for a lot more math content in geometry and much more mathematical subjects. And I hope to see you soon.